Ladies and gentlemen, okay, so we're going to go on now. So the challenge that confronts us, fortified by that new graph as a lens, the challenge that confronts us is putting in place some interventions. So we're going to show two big ways that interventions could be implemented. The second way will take you from the novice level to the intermediate level with AnyLogic. It's a technique most people don't know about. It's a technique that harnesses the power of AnyLogic in a way that is rarely appreciated. So that will be sort of your graduation to an intermediate level of competence. But it will demand a bit of patience for you. So, ladies and gentlemen, I would like to put in place, with an eye towards intervention, I would like to go over to simulation, where it says simulation main. I would like to call this baseline. Baseline. Okay? Now, very importantly, ladies and gentlemen, if you go scan the parameters, you notice that none of these are bold, are embolded. What that means is none of them have been changed from their default values. Parameters are shown in bold if you've changed them, okay? So if I were to go change this, say, to 2, you notice it's made in bold. But I just want to leave it, and this is an indication we haven't changed anything from the baseline. So, ladies and gentlemen, I would like to now go define an intervention, represent at a stylized level an intervention which halves the duration of infection. So it divides the duration of infection by 2. How would I do that? I want to investigate a scenario where we posit some intervention that's lowered the duration of infection by a factor of 2. You can imagine this being associated with screening. You can imagine this being associated with contact tracing. You could imagine it being associated with some sort of mechanism that supports individuals presenting for care more easily, so they could come in for care and get treated more quickly. In the context of a treatment-mediated recovery, we might bring people in sooner and get them treated, and therefore reduce the duration of infection by a factor of 2. So how would I accomplish that? Suppose I want to run this model with half the duration of infection. How would I do that? Create a new experiment. That's exactly right. So let's create a new experiment. Remember, the experiments are where we can ask what-if questions, right? So ladies and gentlemen, to create a new experiment, what do we have to do? Right-click on this and do New Experiment. And this is going to be what sort of thing? Just a standard simulation, okay? And we're going to call it halved duration of infection, okay? Halved duration of infection. And now how would I go about realizing that, operationalizing that, enforcing that? How would I go about doing that? Go in and change this parameter from 10 to what? To 5. There we go. So now we've changed it. It's shown in an emboldened state. Are people comfortable with that? Okay. Sorry? Okay. It doesn't bold. Okay. Alan, do you want to take a look at that? So you changed it to 5 and you saved it? still not, it's not bolded? Could be. It's kind of a nice feature. Okay. Did you move the cursor out of that little thing? Okay. Well, mumble. Okay. So ladies and gentlemen, let's run this thing with half the duration of infection. Okay. First of all, this didn't even take off the first time here. Let me run it again. Nothing that, okay, yeah. Oh, I see. I have this file open, that's why. Excel output. That's what's going on. Let's close this off. Get rid of that message. Okay, there we go. You don't have to worry about that, but in mine it was trying to write to this file that was open in Excel. Okay. Okay, I'm actually not getting this after 4 times. Now, one point of note and a tip. Ladies and gentlemen, one point of note is you'll notice that once again this is getting chronically short of memory. Why is that? Well, I created a new experiment, and now we're back to the same amount of memory that's by default. So a better way to do that, to get around this, would actually be when you're going to create a new experiment, say for an intervention, one thing you could do is copy the baseline after you've set this memory for it, and then you could do paste. And then you'd have a new experiment where it retains the memory settings and all the other settings the other settings that you maintained. And that avoids having to do it every time. In this case, we didn't do that. I elected to just declare it, so I'm going to change that memory setting up. And now, in this context, what I'm seeing is considerably lower likelihood of an outbreak occurring. It seems that it's not occurring with nearly the frequency that it did. But not nearly with the level of frequency. So this is a case of an intervention as implemented in a simple change of parameters. So let's do just to sort of retain the point. I would like to now simulate another intervention, maybe based on social distancing, where the contact rate is lowered by 10%. That is to 0.9. How do we do that? So take into account my suggestion for how to do it most conveniently. What could we do? We could copy the baseline. So we right-click on the baseline, do copy. And now we could go up to the model as a whole and do paste. And now where it says baseline 1, we could say lowered contact rate. Or to be more specific, you could say contact rate 0.9, PT9. Or to make it more visually clear, you could put underbars here, 0.9. We could call it any number of different things, but by virtue of having copied and pasted that baseline, we now have the memory settings corresponding to what we did, and any other settings that we had set below here, like whether we could pan around. We have set any settings for how long to run it. In this case, we're going to set it to have a contact rate of 0.9, 0.9. There we go. Okay. So So I've just run that. And now I'd like to do something a little bit different. I would like to go set it so that we have a standardized way of comparing these. So we're not comparing apples with oranges, but apples with apples. I'd like to run each of these runs for 500 time units. Okay, 500 days. How do we do that? You go down to model time, which is specified on a per experiment basis. And within model time, what would we do? Make it say stop at a specific time, and we'll say time 500. And let's do that for both this intervention, for that other intervention. We really should have done this when it was still the baseline. And then I'd like to do it finally for the baseline, for all three. So we have some common standard of reference by which to compare them. Okay. Now you should be able to run your contact rate 0.9. And in my case, I saw an outbreak, and we could go out and we could look at what the prevalence is. In my case, the prevalence for the two groups varies, well, for the average, the overall prevalence. You notice by clicking on this, you can get it to highlight one particular one. The overall prevalence goes between about 10% and 20% in this lowered contact rate, with the prevalence among low SES being significantly higher and touching 20%. By contrast, that for high SES dips down below 10%, down to about 5%. And gentlemen, I would like you now to go run with the baseline. I want to run it separately for the baseline. Okay. Now, to really make this a reliable comparison, we'd have to run it several times to basically set up a parameter variation experiment. We don't have time to do that, so I just reran it to see it come off here. And here, once again, at time 500, we also tended to have something in roughly the same range. We'd want to run it many times to be able to compare that reliably, but we could set up a parameter variation experiment to do that and to collect that data. But right now our query is a little bit different. Right now what we're going to be doing is we're going to go and go from an intervention that is general across the entire population to one that is specific for a subgroup of the population. So it's very common in the public health arena that we'll not just have a broad spectrum intervention that intervenes in the whole population, but one which will target particularly vulnerable groups and will focus on those groups. So ladies and gentlemen, I'd like to put in place a mechanism whereby we could do this. Are people ready? Are you caught up? Okay, so this is going to be the more intermediate level stuff. It won't take that long, but it will stretch you. Okay? Okay, so ladies and gentlemen, we're going to do something that we've never done before. We're going to go to main. And I'd ask you to go down to the area where you have the population depicted here. Are you there? Are you ready? Okay. Now, I'd like you to drag in a parameter. But this won't be any old parameter. This will be an unusual type of parameter. A parameter type we've never seen before. So I'd like you to drag in a parameter here. And this parameter will be given a name that will seem puzzling potentially at first. Maybe not so. It's called isEligible for intervention. Intervention. Okay? Now, based on its name, what sort of thing do you think that would be? Would it be a double precision value? Would it be a string? Would it be a person? It would be a Boolean, something that's true or false. That's right. So, but this will be a special type of thing. What this parameter will represent, folks, is not a single value. It will represent a rule. A rule for determining if someone's eligible. It's not going to say to the whole model, you are not eligible for the intervention, or you are eligible. That would be kind of strange, wouldn't it? If we told the whole model, you're ineligible, what use would that be? Or you're all eligible, what use would that be? Instead, what this will be is a rule that we can apply to each person that will say, is this person eligible? Is that person eligible? It'll be a criterion, a condition. Does that make sense? Okay, so, ladies and gentlemen, I'd like you to click on this, and I'd like to turn this into what's called a dynamic parameter. Where did I select that? It's down in the advanced area. Do you see that? Do you see that? So who needs TA help? The TAs, stalwart TAs, stand on guard. Okay? 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 Okay. So did you select dynamic? Are you ready to go on? Now you're going to push yourself further. So this will be of type, what do you think type this will be? Your guess was right. It'll be a what? A Boolean. It will return true or false. Okay? And its default value will be false. Okay? Now, ladies and gentlemen, we're going to go where no person in this room, except, yeah, it's gone before, except maybe the TAs. Okay. Okay, are you ready? Okay, we're going to go down to this thing called arguments. Now, that is not about fractious disagreements. That's not about conflict. By an argument, does anyone remember who attended the Java tutorial? What's an argument? It's a thing that it's information a function needs to do its job. It's a piece of information, type of information you pass to the function to do its job. It's similar to what we call a formal parameter of the function. It's something it needs to do its job. So like for a sine, it's the angle that it needs to be given, the sine of an angle, right? You give it an angle, it'll return the value. If you don't give it an angle, it can't do its job. So it is with this. Okay, so we're going to give it an argument, and this argument will be called candidate person. And what sort of type do you think this will be? Do you think that candidate person will be a string? Will they be a double? Well, they'll be a person, darn right. It's one of the advantages of good naming. So, ladies and gentlemen, this will provide us with the ability to specify a criteria for a given intervention. And ladies and gentlemen, because this is a parameter of main, where will the assumption about that be specified? In the experiment. So on a per experiment basis, we could specify different criteria on whom to intervene. Maybe in one case, it's individuals who are between 5 and 9 years old. Maybe in another case, it's pregnant women. Maybe in another case, it's people, children in preschools. We could specify on a per experiment basis, not hard-coded in the model, but on a per experiment basis. Okay? Okay, now, we're most of the way done, conceptually at least. But I would like to now add an additional construct that will also stretch you. And this too was added by dragging a parameter in. But this parameter as well will not be your average parameter. This parameter will be called perform intervention for person. This parameter is going to perform an intervention. How could that be? How could it be that this parameter will actually perform an intervention on a person? Well, first of all, what will it need? If it's going to perform an intervention on a person, what will it need to be told about? Well, okay. It's going to assume that if it's being called, they're eligible. It's just going to do its job. But in order to perform it on a person, what does it need to know? In order to take the sine of an angle, what does sine need to know? The angle. To perform an intervention on a person, what does this need to know? The person on whom to intervene. So, ladies and gentlemen, selecting that, we're going to go down in the advanced area, we're going to select action. It's going to be an action parameter. And what that means is it doesn't actually have a value. It just does something in life. You notice that the request to enter the type of it disappears. Its job in life is to just do something. So, I would like to, as the name here, set the name person on whom to intervene. Person on whom to intervene. And what type do you think it will be? It'll be a person. Darn right, it'll be a person. There we go. Are we okay? I know. It may make your head spin. Now we have these things that look like parameters. They're parameters, ladies and gentlemen, in the sense that they're specified by the experiment. They're specified on a per experiment basis. What criteria to use to judge if a person's eligible. What intervention to perform on those people who are eligible. It's in that sense. Okay. Okay, so ladies and gentlemen, I would like you now to go and add the final bit of logic that we will need. So, yes.
What type of parameter is it?
It's an action parameter. But that's specified down there in the advanced area. And then we have to specify person on whom to intervene. And that's of type person. Right? Yes, Alan?
There's a question about what's the difference between an event and an action?
Because an event, so it turns out that an action parameter won't trigger something, it'll just do something. But the difference is that parameter can be specified on a per experiment basis. If we put an event in that did something, we could do that, right? That's a job in life of events. to fire off at certain times, once or many times, and do something, right? That's how they do it. So why not put all this in the event? Why do we need this action parameter stuff? Because if you hard code the intervention in the event, now you can't vary it on a per experiment basis. You can't ask what if questions with different interventions. We want to be able to, on a per experiment basis, have the experiments be what ifs. What if we had an intervention that focused on this group or on that group, or that did this or that on that group? To have that flexibility, to have the flexibility of varying our intervention choice on a per experiment basis, we don't want to hard code the intervention choice into an event. We want to put it so that it can be specified on a per experiment basis by using a parameter, an action parameter. But as we will see, Alan speaks in a prescient way. So our very next action will be to put in an event. Okay? Are we ready to do this? Okay. Let us drag in an event here. And this event will be called perform intervention. Perform targeted intervention. Okay? Perform targeted intervention event. Intervention event. And it will go off, well, you can make your choice. I'm going to have this go off at just at time 0. You could have this intervention go off periodically. Once a month, you could intervene. Once a year, you could intervene. You could intervene on a regular basis. But for now, we're going to have it go off just one time at the start of the model. Okay? Now, the key thing here will be this code. And as I say, this will be the transition to intermediate level AnyLogic, this whole exercise. So, ladies and gentlemen, what will we need to do if we want to perform an intervention on each, if we want to consider performing an intervention on each person in the population? What 2 steps will we need to undertake? Given these parameters we've added, these 2 parameters, what steps do you think we need to undertake? We need to check if they're eligible for each person, check if they're eligible. If so, perform the intervention on them. So, how would we go through each person in the population in turn and do that? We would need a loop. Okay? Okay, yeah, okay, that's good. I wish I had learned that when I was 8 years old or something. I still owe you the story. So I'll come back to that, I promise. For your dedication on this final day here in the classroom, I'll come back and tell you a good story about a loop. Okay, so ladies and gentlemen, yes?
Why wouldn't you, the is eligible and perform, why wouldn't you do those 2 as the function call?
You could do this, but the fact that we specify them as parameters means that if we had them as functions, that would be fine in main, they do their job, but then it would be hard-coded into our model what the criteria is for our intervention, that you want to do it on kids between 5 and 9 years old or on pregnant women. And it would be hard-coded what intervention we're performing, whether you're lowering the contact rate or lowering the duration of infection or having people have less risk of transmission given exposure. That would all be then hard-coded in the model, so we couldn't vary it on a per-experiment basis. By specifying them as parameters, each different experiment can specify different interventions, which allows us an extremely powerful combination. So we can have interventions as these what-if that are asking about putting in place different interventions. Each of them involves putting in place a different intervention. So this is going to be the final crescendo. Okay? Okay, are we ready? Okay, So we need to do what over the population? We need to loop. Okay? Okay, so we need to loop over the population. That's right. So here we go. For, tell me what to write. For person P, and then what? What do I need? I need a colon. That's right. Followed by person. Okay.
So how do you do person, not population yet?
Oh, sorry, not person. Oh my gosh. Sorry. I stand before you ashamed. For about the fifth time during this boot camp. For person P and the population. Sorry. It's like I regressed. Sorry. For person P and the population, what do we need to do? We need to first check if they are eligible. So, watch this. You don't know how to do it, but I will ask, is eligible for, and look at that. What is that asking for? What is that telling me? I just did autocomplete and I put this. What do I need to put here? P. I'm asking, is P eligible for the intervention? If so, do what? Perform the intervention on the person. And we perform it on P. Isn't that a thing of beauty? Gosh. I mean, for me, that almost brings tears to the eyes. I mean, it's so sweet that we can do these with parameters. The beauty is, folks, that each experiment will be giving different rules for these things. So one experiment will say intervene on 5 to 9-year-old children and in them lower the contact rate, maybe by closing schools for those age groups or what have you. Another intervention may go through and ask is this woman pregnant? If so, we'll give her a vaccination. Another one might go through and seek to determine if this is a person whose immune system may be subpar, and if so, we will encourage them to engage in self-isolation. The point is, each experiment is going to be able to specify different rules here, and whatever those rules are, they'll be implemented here. They'll be tested here. So this is what we need. Do people have that in place? Yes, Robin.
So what was the difference between when you did the autocomplete, it did candidate, and then on mine on the second one, it did person on whom to intervene?
That's right.
In the parentheses.
Yeah.
So what's the difference between that and the P?
Okay. So who created those names? You did. Do you remember where you created those names? Let's take a look just to make parameter. It's in the parameters. So for is eligible, we called it candidate person. Person on whom to intervene, that was named there. So that's where those names came from, right? Now, what would have happened if we had just left those in place? So it wouldn't know what those are. I don't know. That's just telling us what we have to put here, and what we have to put here. This is the candidate person, so we need to specify that. If we had just left that name, we'd say, I don't know what that is. I mean, you're supposed to fill it in for me. That's a placeholder that you have to fill in, if that's helpful.
So essentially what we've done is we've set up the structure, but we still haven't actually determined the eligibility criteria, and that we're going to do.
That's what we're going to do next. We're going to right now build this. Build it. Okay. Are we okay with that? Okay. And now we're going to go to, here's our baseline, and you'll notice that it has criteria here. For the baseline, what's our criteria for whether someone's eligible? For the baseline, nobody is eligible, right? Let's add another one. Let's intervene on low-income individuals. Let's target low-income individuals, and let's say let's halve the duration of infection for those individuals. See what I mean? Okay, ladies and gentlemen, how would I do that? I need to create a new experiment, and the best way to do that, I argued, is to do what? Copy this one and paste it in. So it gets all those other settings, those settings like the amount of memory to give to it, whether you can pan around. Okay? Okay? And we're going to call this halved infection duration for low SES. Okay? Okay. So I called it halved infection duration for low SES. Okay? Okay. Maybe I'm mixing a little bit too much medieval English in here. But yes. Yes.
So, quick question. On the parameters there, it seems like every time you're saving the experiment as what you're doing, is it possible at each parameter that will able to read off a file?
Yeah, to have this parameter read from a file? Yeah, in fact, we did that yesterday. Those who were here yesterday, see right here, we did that to read in from a certain cell of a file, read in the contact rate, or to read in this immunity duration from a different cell within the Excel file. Is that helpful? Yeah. That's what we are hearing. There's a recording of it, even as we speak, that it can be found on YouTube. Okay? Okay, very good. So here's this halved duration of infection for low SES. What criteria will we specify here for this? Well, we want to ask about, ladies and gentlemen, what is our criteria going to involve? Okay, and whose income? The income of the person. And what is that? And this is the key thing, folks. Mark this moment. Mark this point. How are we going to refer to the person here? We want to check if their income is less than $400. Okay, but why P? How do we refer to that person? Well, ladies and gentlemen, mark this. Pay close attention. We're filling in the value here for is eligible, right? For is eligible, the person is called candidate person. So that's what we need to know, ladies and gentlemen. So what we need to do is we need to put here candidate person dot what? Income is less than $400. In which case they'll be viewed as a low SES person. And if so, what intervention do you think will perform? We will do what to them? We'll halve their infection duration. Now, how do we refer to this person here? How are we going to tell it, do it for this person? Well, it's called person on whom to intervene. So we will go and we will say person on whom to intervene dot, what is it called? Infection duration or duration of infection? What is it called? Is it called, what is it called? It's called, it's oh my gosh. Okay. Sorry, an ugly thing is just fly has landed in our soup. Sorry, we need to. Okay, this is the most uncomfortable thing. Okay, ladies and gentlemen, I want to set the duration of infection to be equal to half its value. How would I set it to be half its value? Okay, divided by equal to 2.0. Do you remember that? This means this thing equals this thing divided by 2.0. Remember, divided by equal? If you have A divided by equals B, it means A equals A divided by B. Remember that? Okay, but there's something there's a fly in this ointment. There's a fly in the soup. And the fly is the fact that right now, someone's duration of infection, where does that live? It lives in where? In Maine. We need to move it out of Maine so we could have each person have a different duration of infection. Isn't that right? Okay. So let's do a little bit of heavy lifting. Okay, so ladies and gentlemen, we're going to do something. So if you see me twitching, you'll notice why I don't like this strategy terribly much. But we're going to go to Maine, and we will call in Maine this duration of infection. We're going to rename this to be default duration of infection. That's in the absence of intervening. Okay? Default duration of infection.
That's the one in Maine, right?
That's the one in Maine. Yes, we'll do Control Enter, and it will update all the values for it, and it will show us where those are. And we'll just say OK for these. So it's now done this. Okay. Now I personally don't like having to do this with you, but such is the hand that I have given you. Okay, so I have lent you. Okay. Okay, so I'd like now to go to person, and we need to do what to them? If we're going to be changing this, what do we need to do? We need to add a what for them? A parameter called duration of infection. Okay, TAs, prepare for duty. You may have to help out quite a bit in the next few minutes. Okay, so we need to go to person. So what did I do? I went to Maine, and I renamed this duration of infection to be default duration of infection. I then went to person. Sorry, I didn't design this model to be used in this way, so we're kind of retrofitting it. Okay, and I'd like to go to person and add duration of infection. Okay, so now each person is going to be able to have a separate assumption for their duration of infection. Ladies and gentlemen, each person will have a certain duration for their duration of infection. And where will this be used? Can anyone tell me? In recovery, it will make reference to my duration of infection. We're almost done. So what did we just do? We renamed the duration of infection in Maine to be default duration of infection in the absence of intervention. And that will allow each experiment to still specify it, because we have the extra fly in the ointment that several of our experiments are making assumptions about it. So we set it in Maine to call it default duration of infection. We then went to add to person a parameter called duration of infection. And now in the final sort of bit, we're going to make recovery depend on that person's duration of infection. And then there's just one more thing to be done, and it will be a thing of ease. Okay? So here, where it says recovery, we should refer to this dot duration of infection. That's my duration of infection. Okay? So recovery, so we added a duration of infection here, it's a double, and we made recovery refer to this dot duration of infection. Okay? Are we okay with that? Okay. Now there's just one final thing to be done. What is that? Okay, yeah. So who is going to be setting the assumptions about parameters for each person, like income and duration of infection? Where is that specified? In the population. Remember that? So if we go up in population, we'll find duration of infection. And what will we fill in here? Default duration of infection. So by default, we're going to give this. Why did I have to have this thing default in the main and also in person? Well, the fact is we already had several experiments which were tweaking, which were adjusting default duration of infection or using it. So I didn't want to invalidate those early experiments. So we need to have one here that's used by default, but we can override it on a per person basis. So duration of infection on an individual level will by default be set according to this default duration of infection, which is a parameter given to main. So by default, people have the duration of infection given to main, but the fact that each has their own will allow us to modify it in intervention. So, are people okay with that? Okay? Okay, who needs TA help? Stalwart TAs stand at vigilance. Okay? Okay. Okay, so, ladies and gentlemen, now we need to go back to our parameter, to our experiment, and we want to fill this in. Well, there it is. It's done. If you copied in what I did earlier, it was done. The deed is done. Okay? Okay. Duration is a double. Indeed. Okay? Okay? Are people okay with that? Okay, should we run it? Shall we run it? Okay, now mark my words. You'll notice that we are specifying default duration of infection to be 10. Let us now run this model and let us go see if it's working. Let us go inspect. How would we tell if it's working, ladies and gentlemen? I'm sorry? Well, okay, that could be the impact, but how could we go browse people and see if it is operated correctly? Remember, on whom is it changing the intervention? The low SES. So if we go and we look at the population, okay, this person has a duration of 5. Why is that? They're low income. Their duration has been halved. Or as we might say these days, halved. Okay? Okay, let's go up. Okay, this person has a duration of 10. Why is that? Because they are well healed. They're healed. They're well healed. Okay, so let's go up. This person also has a higher duration. This person has a lower duration because they're low SES. Ladies and gentlemen, we have succeeded in capturing this intervention where we have the rate of contact for those people who are low income, and the if we go and we look at this graph, do you see a difference from before? Does anyone see a difference? What's the difference? Yeah, it's much tighter now. Why is that? You'll notice that these are closer to on top of each other. And while a gradient still exists, it is maybe it's been blunted some. I won't say that for sure. But these are much closer to each other. Okay, so ladies and gentlemen, let's now go and perform another one. So let's copy this experiment. Mind you, copy this experiment, not the original baseline, and let us go paste it in. That will retain for, oh my gosh. It just closed my model, okay, in a most inopportune time. Okay, I'm going to right-click here and do copy, and now I'm going to go up here and do paste here. And now I'm going to, ladies and gentlemen, I'm going to quarter, okay, quarter infection duration for low SES. Tell me what to do differently. Yeah, from 2 to 4. That's right. Okay, and now we will run this. Okay, so we'll run. Okay. Okay, once again, it's kind of going to the state where it's less. And here we do see signs of sort of a lower, and then it rises, and then coming down. So in other words, we've intervened and tended to blunt it among the very lowest income groups. And then at somewhat higher groups above 400, it rises and then goes down. So there's some evidence for that case. And if we were to run it again, I would conjecture that we will see that pattern reduced for cases where it actually exhibits an outbreak. Okay, so here we probably truncated the runs too short, but once again we have sort of low and then high. This will be more manifest if we run this thing to longer than 500. I chose an inopportune time. I'm going to set it to 5,000, in fact, and run it out. And here we go. Okay. And, okay, here we go. Boom. Okay. And one thing you will see is, okay, so it's still running here. Okay. 5,000. You'll notice that this has been very materially reduced. The this burden here, and once again you see this kind of lower and then high and down. So, ladies and gentlemen, this association that we see between income on the one hand and number of times infected at the other, the nature of that association is subject to change based on our interventions. Our interventions, ladies and gentlemen, change associations. Almost by their nature, they shift what Jeff would term the data-generating process. They shift the underlying situation out of which associations arise. And by choosing an intervention here which intervened upon the lowest income groups, we now see a rather different outcome. Let us now browse. I will go browse the baseline for time 5,000 as well, for putting this out to time 5,000. And I will set the stop time to be 5,000. And let us browse that same graph for this baseline. And you will perhaps better appreciate the meaning of my word about altering that association. So here in the baseline, we have this situation where we are not intervening. We run this out to time 5,000. We see both a higher burden of infection, a somewhat greater separation, and a burden of infection in terms of count of individuals infected that exhibits a strikingly sort of decreasing gradient here, with the lowest income individuals having a much higher burden of infection. By contrast, in this case of a targeted intervention, which really decreases it amongst the lowest income individuals, we will see both benefits for the population as a whole in terms of lower burden of infection with this population-wide average sending now about 5%, not the 10% seen previously, 10% or more, actually 15%. And we will see a case where the lowest income individuals have been somewhat protected by virtue of this intervention. Now, of course, the beauty, ladies and gentlemen, of this targeted intervention strategy is that we can then use it very flexibly. We could go, for example, copy this, paste it in again, and we could change once again our criteria to be low, say, and middle income, middle SES. And we could plot what would happen, say, for a focus on, if we were to focus on the groups up to an income of, say, 1,200. We could go examine this and examine that same association, the association whose curve we have bent within our previous efforts. And what lies before you here, ladies and gentlemen? What's going on? Let's run that. What's that? Yeah, we saw the infection starting to spread, but what happened quickly thereupon? Well, here we're running it. There is some, there's very little infection going on. Even the curve there. Let's run again. So in this case, with this somewhat broader but very aggressive intervention strategy, we see evidence of die-out on a repeated basis. So here, ladies and gentlemen, let us not lose track of the key benefit that has been conferred, the key desiderata that have been obtained and realized. What we've been able to do is to put in place targeted interventions that target particular subset of the population on a per intervention basis, dictating not only the criteria by which someone is eligible, but also the mode of intervention. And to emphasize this final point, I'm just going to make one final copy, one final intervention. I'm going to copy this, and I'm going to paste this in here. And I will, I'm going to focus on the low SES, but I'm going to do quarter contact rate, the contact rate for the low SES. How would I do that, ladies and gentlemen? Well, okay, I've got to be careful. You know what that would require? It would require moving this to the person as well, having a person contact rate and setting default contact rate here. We could do it. It wouldn't be painful, and I actually will do it even as we speak. So I'm going to call this default contact rate, and I'm going to do Control-Enter and use it, place references to it. And now I'm going to go to person, and I'm going to add a contact rate here for this particular person. And this contact rate by default will be given by the default contact rate, and the contact rate will be associated with this transition. I'll go change it like that. And then if we go up to main, we will find that this makes use of the default contact rate by, default contact rate has to go here. Okay, so there we go. And now we have this ability to specify default contact rate. Okay, so why isn't that, I put in income. Oh man, I didn't mean to do that. Thank you. I needed to put it here. That's what I was doing. This should be contact rate. Thank you. Okay, I don't know what I was doing. Okay, default contact rate. That's what we need, right? Default contact rate, right? Okay, still an unhappy camper. Default, okay, fine. That's fine. Default contact rate will be specified by that population. And this, it says, there should be this dot contact rate. This dot contact rate. Just like we did earlier. And then this guy here is for the population, specifies default contact rate. That's it. Okay, so now that allows us to specify on a per person basis, specify contact rate divided by 4, for example. So here, we're setting their contact rate with the same criteria, and we could examine the impact of that. So here we have a very flexible mechanism for specifying interventions that allows those interventions to differ both in terms of the criteria for eligibility and the criteria for intervening upon the population. And notice again, we've bent this curve. We've bent this curve by blunting the number of infections in the youngest ages. Okay? So that was a bit about performing interventions with these models. Broadly speaking, we saw 2 types of interventions. We could readily, one type of intervention simply changed assumptions on a broad level across the population. A more articulated intervention, however, allowed us to specify criteria for intervention and the actual nature of the intervention on a per person basis, and that allowed us to examine on a scenario by scenario basis across different experiments, very different intervention mechanisms. Why are we doing this all with these mechanisms? Why not just hard code them in main, what intervention to implement? Well, because then every time we need to write a new scenario, we want to run a new experiment, we'd have to go back and modify main, which would be painful. And as we evolve our model, what we've done is allows the flexibility of intervening in the same way with each revision of the model as it incorporates more texture, additional state charts, additional dynamics. We can reapply these same interventions in that model and see the effects. If we had to go every time and go through successively each intervention type, hard code it, and run the experiment, we could do that, but it would be very painful to rerun your battery of interventions as the model was evolving successively. By separating it out into interventions being captured in experiments and then having a completely generic mechanism for performing those targeted interventions that does not have to change on a per experiment basis, we can allow the model to evolve one way, be successively refined, enriched, but easily go back and rerun our battery of experiments just defined as different experiments, just defined as different scenarios separated out from the model logic. So that, ladies and gentlemen, is the goal to which we aspired, and that, ladies and gentlemen, is the desiderata and the goal that we have achieved. And that, ladies and gentlemen, completes my final lecture for the boot camp.